Ooh, let me turn my volume up down here. Make sure we're okay. Forgot to do some checkings here real quick. Well, welcome to Rational Science. And today we're going to be talking about these gentlemen. In other words, we're going to talk about the Nobel Prizes. Probably heard about them sometime in your life. Okay, and as when we go back in history, we find out that Mr. Alfred Nobel, he was close to dying, right? And so he amended his will, had lots of money in his pocket, and he decided to donate it to philanthropists. Just give the money away to science, especially, right? And social sciences as well as the hard sciences. Okay, and so what was his thinking? He says, awarded to those who, during the preceding year, have conferred the greatest benefit to humankind. Well, sounds like a noble goal. Okay, you give a prize to people, right? Sounds okay. Several outreach organizations and activities have been developed to inspire generations and disseminate knowledge about the Nobel Prize. Yeah, that's what I'm going to do here. I'm going to help them out. I'm going to inseminate or disseminate whatever the Nobel Prize. I want to make sure that people understand what the Nobel Prize is about. So, what is the Nobel Prize? Well, let me give you something that happened about the same time that the Nobel Prize was created and Alfred Nobel died. Okay, he came from a rich family, also of oil barons. Okay, his brothers, his father, and they lost money. They wanted back, and so on, but they ended up in good shape. And about the same time, in the 1895, 1896 time frame, when Nobel was creating his Nobel Prize, something else happened. And that was that you had this Baron, Pierre de Coubertin, a French guy, and he reinstituted the Olympics, okay, the Olympic Games. And you say, well, Bill, what's that got to do with the Nobel? Well, let me tell you a little story, and you'll see what it has to do with a Nobel. Turns out that 800 years before Christ, actually the date has been zeroed down to or pinpointed as 796 before Christ. And those were the first Olympic Games. And it started in the little town or village or city-state of Olympia in Greece. And all the Greek city-states sent their best athletes over there, and they competed for the wreaths, for being who was the champion, right? In running and javelin throwing and wrestling, whatever. But that was the first Olympics. Then over time, the Olympic Games became professional. What happened was that the stake, the honor of the city state was at stake there, and so they said, "Oh no, next time we're going to win. We're going to win the race, or we're going to win wrestling, or whatever." And what happened was they started creating these superheroes that all they did was train for the Olympics. So they didn't go to war. They didn't have to work in the fields. All they did all day was train for the Olympics, and they were subsidized by the rich folk. So when the Olympics came, the records improved because now you had people who were professionals who practiced every day for 4 years before they, competed in the Olympics. Well, in 1896, when Coubertin finally created the new Olympics, they said, no, it's got to be amateur. Okay? They did not allow any professionals. In fact, there was a case, Jim Thorpe, an Indian fellow from Oklahoma, and he won the decathlon in the first Olympics, or not in the first, but like a fourth or fifth. And they took his medal away. Why? Because he had played some semi-professional baseball or football or basketball. They found out about that, and they said, "You're a professional," and they took his medal away. They reinstituted his medal many years later, out of compassion for him. But they took his medal away because he was a professional. Well, of course, that over time, they did allow professionalism in the Olympics because it was all these big companies that essentially underwrote the Olympics. You have companies like NBC, ABC that want to have a monopoly on transmitting the Olympics, and you have a lot of companies that want to advertise during the Olympics. And so there's a lot of money flowing in there. They finally said, "Hey, hell with it. We're going to allow professionals as well." And now you have professional teams like soccer teams. You have professional basketball teams. You have professionals, a lot of professionals. In fact, it's becoming more and more professional with people who just practice during 4 years before going to the Olympics. Everybody's a professional today in the Olympics. And the question is whether you can do that with science. Does it make sense to receive prizes like gold medals for science? Imagine, because I think they're not compatible. Imagine they gave medals for example, religion. Okay, so this year the Buddhists win. They say, "Oh, we've got Buddha, and he was the greatest." And the Muslims say, "Oh, next year we're going to win that medal. We're going to have Muhammad. He was the greatest prophet that existed." And the Christians come in the third year and say, "Oh, no, we're going to win next year." Does that make any sense? Winning medals for religion? Science, we need to figure out how gravity works, how magnetism works, how light works, how the atom works. You don't get medals for that. It doesn't make any sense. It's like saying, "Oh, next year I'm going to invent a better way of doing magnetism, or a better way of doing gravity." Does that make any sense? What all these people do, mathematicians, they say, "I've got a better equation." Like, Einstein's equation was a little more accurate than Newton's equation. Should you get a medal for that? And now people are working on the next level. They say, "Oh, we're going to get a better equation than Einstein's." Is this a question of accuracy or getting a medal for that? Or is it a question of saying, let's figure out how this universe works? You don't get any medals for that. It doesn't make any sense to put medals in that situation. And that's, I think, what Mr. Nobel did. He probably had good intentions, but I think they worked in the wrong way. And one of the reasons for that, that I'm saying that, it doesn't belong in there, the medals, is that you have all these people that now for 100 years, over 100 years, they've been winning medals. And they've been winning medals for what? For going out there and saying, "Oh, we found the equation for quantum mechanics or for relativity, and this guy has a better equation than the other guy." And so we're inventing equations, and here we are, 21st century, 2020, and nobody can tell you how gravity works, how magnetism works, how electricity works, not in a rational manner. And so what are all these gold medals that they're giving out for? I mean, here we have 100 years of medals, and what do we have? We have not a single explanation for how Mother Nature runs her shop. So yeah, I don't agree too much with medals. I think they distract from the purpose of science. People worry more about winning the medal than about explaining how the universe works. That's what I see. Right? Anyways, if you look, you'll find that there are a bunch of medals. These are the list of medals they give out in different disciplines. And each one of these is given by different countries. And you have tons of medals out there in different branches, different countries, and they give medals out. I mean, I thought the Oscars and and all these prizes they give out there in Hollywood for best actor, I thought those were just tremendous. I mean, they give medals even to the guy who scraped the floor, in the set. They give medals to everybody there, and I thought those were a lot. But science has a lot more medals than Hollywood has. Do we need all these medals out there? You have medals of all kinds out there, and now because you have the Nobel medal that's given by Sweden. That's Europe. So the United States had to create its own medal. They said, oh, no, we're going to create our own medal. I'm sure China and Russia have their own medals. And so one of the medals that now has taken over, at least as far as money is concerned, it's trying to become as popular as the Nobel, as prestigious as the Nobel. And that's this from the Breakthrough Group, the foundation. And it says, launched by Yuri Milner in 2012, the aim of the Breakthrough Prizes is to recognize what? The achievements of scientists. That's good, maybe, if anything, right? Raising the public consciousness of scientific research and make what? Rock stars of scientists. They want to make rock stars of scientists. They want you to believe in these guys and to adore them and to worship them and ask for their autographs, film them, interview them. Is that what it's all about? Is that what science is? About having these superstars, rock stars up there in the platform talking on a microphone and you saying, oh, I wish I could have his autograph. Is that what science is about? Is that why we need these prizes? And yeah, you can see that several people are behind it, rich people. Mark Zuckerberg, I guess some of you know him, and his wife Priscilla Chan, Sergey Brin, and so on. All these people, rich people, they fund these contests, these beauty contests, these gold medals, Olympic gold medals, to become what? Rock stars? So that people just ask for their autographs? Think about it. Okay? And yeah, it says it's double the price of the Nobel gold medal, right? And it's the 21st century Nobel. So they want to replace the Nobel. They want to say, look, we've got a better prize here, more money. It's about money. It's like, come to our side. We're going to give you money if you come over here. We're going to recognize you. We're going to have you on our team. Then we're going to list you. And maybe in 100 years, we'll have, a better record than the Nobel Prize. It will be more prestigious than them. Think about all that, what they're doing here, okay? And this one is another important one. It's known as the Templeton Foundation. And John Templeton, he gives out prizes for anyone who can merge religion with science. Now, how's that for a goal? You see what these medals are doing, they're giving medals. They say, look, if you can tell us how science and religion merge, hey, we're going to give you a medal. And so a lot of people are going in that direction and they're forgetting about science because now they're saying, well, if I want to win the medal, I don't have to work on science. What I have to work on is on merging science with religion. And what they're doing at the John Templeton Foundation, they created a medal, right, known as the Black Hole Initiative. They gave $7 million, okay, to the Black Hole Initiative. That's in 2016. Maybe they gave more now. An interdisciplinary program at Harvard University that includes the fields of astronomy, physics, philosophy, and is said to be the first center in the world to focus on what? The study of black holes. Something I want to talk about today because this year's Nobels went to black holers, people who talked about or made their careers around the black hole. And it shows some of the people who received the benefits of these prizes, okay? Okay, so who won it this year? Who won the Nobels this year. Well, we have these people here. We have Mr. Penrose. He's a longtime mathematical physicist. He worked with Stephen Hawking in the 60s. Became famous for kind of promoting the black holes in different ways. They wrote a couple papers. And what did he get his medal for? For the discovery that black hole formation is a robust prediction of the general theory of relativity. Okay? And then these other two, I guess they won the silver medal because they only got a quarter of the price each. You know, when Nobel put out his will, he said that no more than 3 people can receive the Nobel Prize. And for many years now, at least, you know, several people receive it every year. It's like 2 or 3 at least. Not one. See, at the beginning of the century, of the 20th century, it was like one person received it. You know, like William Röntgen, who invented the X-rays or discovered the X-rays. Well, he was the only guy. But now, since, you know, it's long gone, for a long time now, several people receive it at the same time, and they break it up. And thank God he said, oh, no more than 3 people. Because otherwise, you know, if they gave it to 100 people, you know, they wouldn't be able to pay their trip back to their countries after they went to Sweden. You know, they'd get 15 cents apiece. So what did Genzel and Andrea, Ghez. Andrea Ghez. I like that. Gee whiz. For the discovery of a supermassive compact object at the center of our galaxy. Okay, so again, I am supermassive. Looks like she's talking about, or they're talking about, black holes. And yeah, since they split the prize, I guess they got second best, silver, maybe bronze medal, I don't know. Here you can see him on the podium, okay? And we have Mr. Penrose, number 1. He's the gold medalist, I guess, right? Mr. Genzel, he gets the silver, and I put Miss Ghez there, third, because I don't know if she's so important. Maybe she was given a medal just to comply with the diversity quota. You know, there are not too many women that enter science. I know this because of the amount of people who come to my site, and I'm sure it's the same everywhere. You know, women are into, mainly are into cosmetics, fashion, different things. They're less into science. Science is still more a man's world. Whether this is by conditioning, many hundreds of years where we condition women, or simply they've grown not to accept science, or they have something else undermined, I don't know. The issue is that women are not much into science, and so they kind of stimulate women to come into science by giving maybe a prize to Andrea Ghez, I guess how she pronounced her name. I like Ghez. You know, Andrea Ghez. Maybe so that other women say, hey, you know, this woman won a Nobel, it means I can win a Nobel too. You know, that's politics. It's got little to do with merits. And so the question is, does she deserve her medal? Okay, this is what I'm talking about. Well, let's find out. What do these folks get their medals for? Well, here's Mr. Penrose. Okay, and what did he do for mankind? Well, he, together with Stephen Hawking, he created or wrote a few papers, primarily in the 60s. So this is more like a lifetime recognition for his work. Okay, and so you can see something of what Mr. Penrose is about. It says, a singularity in solutions of the Einstein field equations is one of 2 things. A situation where matter is forced to be compressed to a point, space-like singularity. A situation where certain light rays come from a region with infinite curvature, a timeline singularity. Okay? And so it says, this is out of the Wikipedia, the Penrose theorem guarantees that light rays are always focused together by gravity, never drawn apart. And we talk about geodesics a couple videos ago. Okay. Hawking's singularity theorem is for the whole universe and works backwards in time. It guarantees that the classical Big Bang has infinite density. Infinite density? That sounds quite a bit like a black hole, and it sounds like a singularity. It sounds like there's no volume, no diameter, no radius. That's why it's infinite density. You put 1 gram of anything into an into a zero volume, and you have infinite density. It doesn't matter how much it weighs, how much matter there is. If there's zero volume, that's how you get infinite density. That means that these folks are talking about a black hole, which is allegedly the starting point of our universe, and they're saying it was zero dimensional. There was nothing there. Okay. In general relativity, a singularity is a place, okay, is a place that objects or light rays can reach in a finite time where the curvature becomes infinite. Curvature infinite, again, zero, they're talking about zero volume. That's what they're talking about. Or space-time stops being a manifold. You have no object in front of you. That's what they mean by that. They use all these fancy terms, but they're saying there's nothing in front of you. That's what they call a black hole. Singularities can be found in all the black hole space-time. Yeah, because there's nothing there, so you can't find anything in nothing. I mean, if there's nothing there, no volume, no radius, no diameter, no size, then I don't care what's in there. We call it nothing. One cannot predict what might come out of a Big Bang singularity in our past, or what happens to an observer that falls into a black hole singularity in the future, like if that mattered at all, right? So they require modification of physical law, no doubt about that. Yeah, you got to modify physics to get some of these ideas through. Before Penrose, it was conceivable that singularities only form in contrived situations. The singularity theorems prove that this cannot happen, and that a singularity will always form once an event horizon forms. So we have a singularity which has no size whatsoever, and they will form no matter what. In the collapsing star example, since all matter and energy is a source of gravitational attraction in general relativity, the additional angular momentum only pulls the star together more strongly as it contracts. That means you have an acceleration of contraction until you have absolutely nothing, known as a singularity. And this is too big here. I mean, I'm talking about nothing. A point, nothing, no size, no diameter, no dimension, no nothing. Okay, so they're talking about nothing. I want to make sure that's clear, because a lot of people out there are saying, well, a black hole is not zero, it's not zero dimensional, not no volume. It's just infinitesimally small. No. It's zero dimensional. That's what Hawking and Penrose proved mathematically. Let's get that straight. They proved that zero dimensional. And they weren't the only ones. Chandrasekhar had done that, and others have done that as well. The word in academics out there is that a black hole is zero dimensional in size, in volume, in diameter, in dimension. There's nothing there. And when people say, well, no, that's not what they say, it's because they're ignorant. They don't know what these people are saying. They should read a little more and, instruct themselves correctly, okay? Educate themselves. Okay, that was what Penrose got his Nobel for. He theorized, he did a couple equations, and that's what they're paying him his money in Sweden for, okay? How about Genzel? Okay, here's Mr. Genzel. I can get him in there. He says, well, we can't see black holes as such. We can see that they're there and what they are through their interaction with visible objects like stars, like gas in their vicinity. Okay? And what he did was he looked at a couple of those stars, okay? And then he plotted this with his computer, okay? He looked at this for over 13 years. He looked at it, the trajectories of 30 stars in the region of the center of our galaxy, Sagittarius as it's called. And he looked at stars in that region. He says he calculated their mass, he calculated their speeds, their orbital speeds, And so he came up, he said, well, there's no way you can explain this other than black hole. There's a black hole somewhere in the center of our galaxy, and we've proven it. What else could it be? That was his reasoning. Okay, what else could it be? And this is more or less like this. Here you have the mime, and the mime is sitting somewhere. What else could it be if not a chair? I mean, we've proven that the mime is sitting in a chair, that there is a chair, because what else could he be sitting on? Okay, that's Mr. Genzel's reasoning. Okay, and he went through this this little reasoning process. First, it took him 10 years to develop some infrared scope to see the stars over there in the Milky Way. Okay, so that took him 10 years. This is what he spent his time on. This is what he's getting his Nobel for. Okay, then he spent 13 years observing and calculating, measuring all these stars and calculating and putting them in a computer and figuring out their orbits, right? And then from that, you know, he calculated one of the stars was 180 billion kilometers traveled, 180 billion kilometers in a matter of a couple of weeks. And he said, man, that thing is so fast, it's almost faster than light. Okay, you got to listen to, you know, what they're talking about here. They're saying this star traveled almost at the speed of light. Remember, Einstein said you can't travel, matter cannot travel at the speed of light, becomes energy. These guys are talking about, you know, almost the speed of light. Just imagine a star traveling that fast. And so he mapped 30 stars in the galactic center, determined the mass and speed of these stars, calculated mass of the central object, and he concluded that it had 4 million times the mass of our sun. And so he said, what else can it be if not a black hole? What else could it be? Okay. We showed the other day what it could be. Okay. There is an alternative. Okay. Okay. And so he wrote this paper. He wrote one of these papers in, what it was, in 2010. Let me get this thing here. Let me get it out here. That's the paper he wrote. Okay. You can look it up and read it. And so he concluded after this. He said, scientists confirm, this note came out about 8 years after he wrote that paper. He kept writing papers all along for several years, right? And he was studying these stars. He was trying to promote his idea that there is a black hole at the center of the Milky Way. He said he proved it because what else could it be? And so by the year 2018, he finally made a dent because he published a paper, and that paper was, you know, everybody more or less parroted it and spread it around. You know, you can look it up. October 31, 2018, you'll find several mentions of this in many newspapers and so on. And more or less, the titles, this was one title, but they all say more or less the same thing. Scientists, Genzel, scientists confirm massive black hole at the center of our galaxy thanks to exciting new discovery. Okay, and what does Genzel say in one of these articles? He says, this always was one of our dream projects, but we did not dare to hope that it could become possible so soon. The result is a resounding confirmation of the massive black hole paradigm. He proved the existence of black holes. Okay, so if he proved the existence of black holes, what was there left for Andrea Ghez? Okay, let's find out. There it is. Well, here it goes. It says, Genzel was a postdoctoral fellow at UC Berkeley, hinting that the center of our galaxy harbored a massive black hole, though the evidence was weak. Genzel worked steadfastly over the ensuing decades to prove his case. Okay, so he wrote a lot of stuff. He did a lot of work on this. Okay, that's what he spent his time on. This is what people paid him for. He developed a remarkable technique in which he can measure very accurately and determine quite precisely the mass and behavior of stars circulating around the galactic center. Okay, fine. He and his colleagues cemented their assertions in 2002. Remember, 2002, he's going to be recognized in 2018. 16 years he was working on this stuff, publishing, right? When they reported the orbit of a star around the galactic center and concluded that it circled an object with the mass of several million stars like our sun. So here comes Ghez now. Ghez led a competing team at UCLA that confirmed this finding. Okay, that's why they split that silver medal in half. You know, because she just confirmed. She wasn't the one who discovered the one that proved. That was Genzel. She just reconfirmed. Okay, she reproved. As both groups mapped the galactic center with increasing precision using the world's largest telescopes, they provided the most convincing evidence, yet of a supermassive black hole at the center of the Milky Way, an extremely heavy and invisible object about 4 million times the mass of our sun. In other words, what these people did was work on proof, on evidence, on convincing people that there is a black hole. Okay, proof, is an opinion. Do you prove God? The existence of God in the center of the Milky Way? I mean, we can just as well say that. That's a question of belief. You want to believe in black holes and God, yes. You can say they proved it because you're convinced of it, not because the world is convinced of it. Ghez research employs high spatial resolution imaging techniques, such as the adaptive optic system at the Keck telescopes to study star forming regions, and the supermassive black hole at the center of the Milky Way known as Sagittarius A. The high resolution of the Keck telescopes gave a significant improvement over the first major study of galactic center kinematics by Reinhard Genzel's group. So all that Andrea Ghez did was confirm Genzel's proof, and that's why she's on the list. And again, is that just politics to make sure that women also get a prize? We take care of the diversity quota, make sure that women also get a prize, so it stimulates women to go into science. Is that what it's all about? Stimulating just people saying, oh, I'm going to go into science because maybe I can get a Nobel. Is that what the purpose of the Nobels is? My God. Okay. So yeah, we have all these rock stars now. That's their function. And you might say, well, Bill, the problem with you is that you didn't get a Nobel medal. Probably have no chance of getting one. So you're upset. You're ticked off that you're not getting one. Well, let me tell you, let's cover that base, okay? And I'll give you a little example, a little analogy. What if my countryman, Pope Frankie, he consults me every day on physics, calls me every day. And one day he calls me and says, hey, Bill, do I have great news for you? Oh, okay. What do you have, Frankie? And he says, we're going to canonize you. We're going to turn you into a saint. Saint Bill. Yeah, well, I don't think, thank you, I really appreciate it, but I don't think I'm the appropriate guy because I'm not Catholic. Maybe you should bypass me, okay? Find someone else. And he said, well, you got no say in the matter, Bill, because, see, the cardinals, the bishops, the abbots and priests, they've all voted, and you're going to be a saint, whether you like it or not. Oh. And it turns out tomorrow, I walk down the street and someone would say, you Bill, all you Christians, all you Catholics, you've tortured people during the Inquisition, you burned them at the stake. So no, you got it all wrong. I'm not even Catholic. Yeah, you say that, but you're a saint, aren't you? And saints don't murder people. So you see where I'm coming with this. So here, the Nobel committee comes tomorrow and says, Bill, you get the Nobel Prize. And what does that mean? That means that I'm going to be in the same church as all these people for 120 years that have been receiving Nobel Prizes. I'll be there with Einstein, with Bohr, with Feynman, with all the Penrose. Do I want to be in that group? No, I don't think so. They can keep their little medals if they can do something with that. Okay? I don't need a little medal. Okay? So, no, I don't want to belong to that group under any circumstances. I've got my own church. Okay? So, no, I'm not jealous of them whatsoever. In fact, I argue the opposite. We shouldn't have any prizes in science. Okay? And there's an interesting story here that you should be aware of. Okay? And this is what happened to a fellow in the 1920s. Okay? He was given a medal, okay, in 1926. Johannes Fibiger, I think that's the way you pronounce it, is awarded the Nobel Prize in Medicine for his purported discovery of a parasite that caused cancer. Okay? Fibiger's discovery was unchallenged during his lifetime. He died of cancer in 1928, 2 years later. So while he was there, he had his medal, okay, he went home, and then he died, right, of cancer. Several subsequent studies showed that the tumors due to neoplasticum in rats were non-cancerous tumors, and that the tumors were primarily due to vitamin A deficiency. So they couldn't get their medal back because they had already given the medal to this fellow, and now he was dead. Okay? To avoid repeating this embarrassment, the awards increasingly recognized scientific discoveries that had withstood the test of time. So now they don't just give it the first guy that comes in there with something, say, I got something new, and they give him a medal. No. We're going to wait until the word spreads around, we confirm, let's take our time. Okay? According to Ralph Peterson, former chairman of the Nobel Prize Committee for Physiology or Medicine, the criterion the previous year is interpreted by the Nobel Assembly as the year when the full impact of the discovery has become evident. Okay? So now let's do a little, let's do a Gedanken experiment, a mental experiment here, okay? Let's assume that God doesn't exist. Now, we all know that God exists. Of course God exists. I'm just asking you to pretend, okay, to make believe that God doesn't exist. Can you imagine what a world we would have if suddenly God did not exist, everyone was aware that God did not exist? Of course, it's unthinkable, right? Now imagine, and again, I'm just asking you to make believe. We all know that black holes exist. It's a proven fact, of course. But let's just assume, let's make believe, let's play, okay? Play the game, okay? Let's assume that black holes don't exist. No. Obviously, it would be so terrible to even ponder that possibility that black holes don't exist. No, black holes had better exist, because not only would a lot of people lose their jobs and their medals, but people would lose a lot of faith in all these so-called scientists out there. So no, black holes had better exist. Okay? Yeah, so forget about that game, make-believe game. It never happened. Never happened, never will. Okay, so what is a black hole? Let's find out. These guys proven the existence of black holes. I went over that last week. Let's go over it real quick. One person says the black hole radius is 0. And that's from the Perimeter Institute. Okay, another group, NASA, says the point of zero volume and infinite density. So how big is a black hole? Well, it's like nothing. That's how big it is. Okay, it's not infinitesimal. It's less than infinitesimal. It's 0. Nothing there. Okay, more evidence, more authority, more proof. Okay, I showed that the other day. I'm not going to read it all again. Just say that Chandrasekhar won his Nobel Prize for proving that black holes are zero-dimensional, that nothing could stop the collapse of a star. It would collapse to zero size, and that's essentially what I just said about Penrose and Hawking. They prove that a black hole collapses to zero size. There's nothing there. Not the black hole, I mean the sun, a star, collapses to zero size. And what they're saying is mass remains there, but there is no structure. And what is mass? Mass is the quantity of matter. There is no matter because it's crushed out of existence. And so what do we have? We have no mass either? I mean, I don't know. You figure it out. And here we have more testimony, okay? We have these folks that say that all matter inside a black hole, anything that falls in there, is crushed out of existence. There is no structure whatsoever inside a black hole. Okay? And we have one little more testimony here, I think. Yeah, what is a black hole? Here it is in perfect scientific mode, scientific jargon. Okay? It's a region. It's an abstract concept. Max Planck Institute, a black hole is not a tangible object, but a region in space. Region is always of something else, therefore a region is not a standalone object. The palm, if you cut the fingers off and you show the palm, that's not a region anymore. The palm is only a region when it's part of the hand. You say the palm is a region of the hand, always of something else, right? But if I cut off the fingers and just show the palm, then it's not a region of anything. It is the palm. It's a standalone object, okay? And again, this Stanford Encyclopedia says a black hole is a region. There is no physical standalone object called a region. So from every point of view, from the point of view of the philosophers, of the physicists or mathematical physicists, mathematicians, all these people say the black hole collapses to zero size. It's a region. It's a concept. You're staring at nothing. There is no standalone object called a black hole. Please spread the word because a lot of people out there believe that there is a physical standalone object called a black hole, and 99.99% of them are mathematical physicists. That's where the problem is. These are the people who rule the world, and these are the people who believe that they're dealing with something when it's obvious that they're dealing with absolutely nothing. What is a black hole? Well, here you have what I showed the other day, and that's that a black hole is really the magnetic field of the galaxy. And you can see the galaxy, they never paint the magnetic field because they can't see it, okay? But a magnetic field has the potential of moving a charged object like a star around in circles, like you see there on the upper left. Inside here on Earth, right? We don't have to go out there in space. If you put a charged ball in a magnetic field, it'll twirl around like you see there. And the magnetic field, a rotating magnetic field, also has the ability to suck in smoke like you see there, and it can also, in the same way, rip the skin of a star, which is what they observe out there in space. So we don't need this notion of a black hole and to deal with mass and gravity, because this can very well be explained with the magnetic field of a galaxy. Okay? So this is the first issue. But then there's another tiny issue I want to mention here, and that's this. People see this and they say, oh, I know what that is. That's a, what is it, a black hole, the jets of a black hole in the center of a galaxy. So they show you this and you say, okay, I see what that is, all those things sticking out there or coming out of the center. They see it as a geyser, just erupting. And there is a possibility that what they're staring at is this. They're staring at the magnetic field of a galaxy sprouting from the center, going north, or north in this case, right, in this vantage point, and going around the galaxy. So what we're staring at is the magnetic field coming out of the center of a black hole, and not jets of the center of the galaxy, and not jets coming out of the center of a black hole that is located in the center of a galaxy. And of course, if you have stars close to the center of the galaxy, for sure they're going to be moved around by these magnetic fields. They're going to be moved around very fast. Okay, because the magnetic field has to be very, very strong near the center of the galaxy. And the issue here is that you'll never see the mathematical physicists include the magnetic field of a galaxy. I mean, we know there's got to be a magnetic field of the galaxy, but it's like we don't see it and we don't care about it, and they just talk about black holes. But when you look at, for example, the sun, okay, and here you'll see with the sun, because we can see that here, they will put the magnetic field of the sun, okay? And it's that magnetic field which extends so great that it protects us against interstellar magnetic fields coming from the galaxy. Okay, so if you see our star, you see the magnetic field is extremely large compared to the size of our sun, and there you see the jets of our sun, okay? And that's what protects us in interstellar space. And here's another notion of that. Okay, here you see the sun throwing its jets. Okay, and those are not black holes. What you see there is simply the magnetic field of the sun pushing outwards a lot of the fire, the heat of the sun. That's what it is, those flares. There's no black hole there. And the galaxy has to have this same phenomena happening into it. And the question is, why don't they illustrate, why don't they account for it? No, they always put a black hole there when they want to illustrate the jets. They do not use, this magnetic field to illustrate what could be happening in the center of a galaxy. So you figure it out. Do we need all these Nobel Prizes? Do we need them to study black holes for how many years? 23 years at least for Genzel? Plus a few more trying to persuade and convince people? How about Penrose? Penrose has been at it for 50, 60 years of his life. He's almost 90 years old. And he's been peddling the black hole at least since the 60s. Of course, he's moved on to other fields. He's gone into, the mental stuff like consciousness. That's what his latest books are about. He's given up on physics. He can't explain anything in physics, so he's moved up the conscious ladder. Everybody does that. They start with physics, then they say, well, how does this physics work in our consciousness? And Genzel is in the same boat. Once he's finished with black holes, he's out of it. He got his Nobel. He's done with it. Now he's going to go into first maybe the talk circuit, and then probably into writing books about consciousness. Become a Buddhist. So that's it for the good old Nobel this year. Okay, let's look at some of the questions and and some of the comments that people made. Here we have this gentleman, and he says, okay, so I called my electric company and said, you can't bill me. Energy is a concept. I can't buy blocks of a concept. She said, sir, you're getting billed in kilowatt hours. Okay. Okay, let's see what the answer to that is. Okay, let's find out. Give me a second here. Okay. And so here's his answer. Until you define the concept scientifically, let me move this over here. Okay. Until you define the concept scientifically, neither the electric company nor anyone has any idea what you're talking about. So can you tell us what a concept is before, so that you can use the word scientifically, okay? And then it's interesting that he writes another comment, and he says the following. He says, I'm 99% solar, a small generator for 1%. I don't pay an electric company that sells in units. I don't know. We got a problem here. You're calling the electric company because they're billing you. They're billing you for electricity that you produce. What do you live in? Where do you live in? North Korea? Okay. Yeah, okay. File continues. I went down to the hardware store and asked for a foot of invisible, intangible, double-twisted ropes acting as a physical mechanism in one string. He giggled and said, I don't think I can help you. Uh-huh. Okay, let's see what the answer to this one is. Of course he can't help you. He meant that he can't sell you things like air in his store, which are invisible, or triangles and circles, which he can't touch in order to hand them to you. Okay? You should have gone to Mother Nature's store. She's got so many intangible and invisible threads that she has a sale on them. But whatever you do, don't ask her for a field. She wouldn't have the foggiest idea what to give you. Okay? She doesn't carry such concepts in her store. So what is a field? If you look it up, influence of some agent existing at all points in space, or a quantity. So yeah, you can't touch a field. You can't give a field. You can't do anything with a field because it's not a physical object. Okay, you can't transfer a field. You can't stretch it. It's like space-time. You can't do anything with a field because there's nothing there. Okay, so whatever you do with a field, certainly you can't go into the hardware store and ask them to sell you a field. No, you got to buy a physical object. Okay. Okay, another comment. I think same fellow. And he says, I asked him, how many circles do you have in stock? He giggled and said, I can't help you there either. Okay, see what the answer to that one is. Okay, and so here it is. Did you ask him for a hammer you are imagining? Does he have that hammer, the one you have in here? Did he have that one in stock? Yeah, imaginary items. Imaginary hammers are objects too. The word hammer always refers to an object, okay? So whenever you say hammer, people think of a hammer, you know, a physical object, no matter what. The one that you're imagining, the one that's real, the one you hit your finger with, it's always the word hammer represents an object. Like the word rope. Rope is always an object, no matter what, never a concept. Okay? Not when you point to it and say, that's a rope, can't be a concept. Now you're pointing to an object. Why? Because it's that which has shape. Okay, and same comment I said. Then I asked him to sell me any kind of a liquid that doesn't take the shape of its container. He said, sir, there is a mental health facility right down the road. Let me get the address. Okay. Let's find out what the answer to that one is. Okay, here it is. You shouldn't have troubled yourself or the hardware store. Man, I could have given you the address. The address he was looking for is located almost exactly between the Earth and the Moon. When you do your spacewalk, you will find that the liquid has shape, although it's not in any container. Okay? And I think I talked about that the other day. Let's illustrate that. Okay, here it is. Here you have water in space. There is no container. And all I'm going to ask you, any of you, is, does that thing have shape? Okay? That's homework. Think about it all week long to tell me whether that has shape or not. Okay? There's water without a container, just floating in space. Okay? Simple? Well, I don't know. Some people it's very hard. Okay, here's another issue. Let me get this straight here. I went back to measuring the fields in my magnetic experiments. Okay, so let's find out. And what is it that you measured? What did it look like when it was completely still? Please draw this standalone field thingy you extended or placed your device across so that we can all be on the same page. A link to an internet site will do, of course. So you can define the term. If you define it, obviously it's not a physical object, so you better not define the word field if you think it's an object. And if it is an object, then you have to just point to it somewhere on the internet, find out, what it looks like. So it's either a concept or an object. There's no other possibility. If it's a concept, you define it. If it's an object, you point to it because it's got shape. And we can all see it, and we can all say, oh, I see what a field is. And it's got to be a standalone object. It's got to be the only object in the universe. No motion, just itself. No location. It's the only object in the universe. So please draw it. Or show us an illustration where only for example, the magnetic field is there. And forget about the magnet. We don't want to see the magnet. We just want to see the magnetic field, okay, and see what it looks like. Want to know what that is. Is that what it is? A field? Bunch of vibrating numbers, values around a center? Is that what a magnetic field is? What an electric field is? What a gravitational field is? Bunch of values? They get weaker as you get away from the center of the object? Yeah, a field is not a physical object. Nowhere. You can't point to a field. So whatever you measured, it's a word that you're using to designate something you still don't understand. You haven't visualized what a field is, so that's what you're measuring. You can measure vibrations, but the issue is vibrations is not a physical object. What you got to identify is the physical object that is vibrating. That's the way it works. Okay, and here it is. Could you treat the thread as the only object? Everything from rope up to galaxies is just a particular arrangement of threads. Yeah, of course. Here's the ultimate or the fundamental hypothesis. And this is what it looks like. It's all these atoms are interconnected because a single thread comprises the entire matter in the universe. They twine around itself, the thread, and it creates all these ropes, which eventually lead to atoms, which lead to ropes, which lead to atoms. So yeah, you could say that there is a single object in the universe, and that's the thread. Obviously, that's not very practical. That's just, to conceptualize what our universe could be, what it really is. And we say, okay, there's a single thread in the entire universe. I think it's got to be a closed loop. Maybe someone comes up, with a better mousetrap someday, I don't know. But it's a single thread, and that turns into ropes, which turn into atoms, which turn into ropes, which turn into atoms, and so on down the line throughout the matter in the universe. And you might say, well, that's a lot of atoms. Yeah, there are a lot of atoms in the universe. So numbers is not something that's going to make your case. Don't say, oh, that's impossible to imagine. Well, I'm sorry. Whether you go with quantum mechanics, the rope model, or whatever, ether, you're going to end up with the same thing. We have tons of galaxies, each one with tons of stars, each star made of tons, gazillions of atoms. So numbers is not an issue. This is not an issue of numbers. This is an issue of conceptualize how the universe could be built, how it's structured, how it's manufactured. Not manufactured in the sense that we constructed from zero, but in the sense of constructing all the atoms. What are they made out of? Are we talking about little discrete particles that come together and interact? Or are we talking about something that is totally connected, the whole shebang, and that all these components are banging against each other and forming molecules and so on. It's a different model. That's all it is. And yeah, you have to conceptualize it under those conditions. Okay, okay, and final question or comment here. See what this gentleman has to say. It says the objects exist. Yeah, the objects can be represented by 3 dimensions. Yeah, okay, let's continue. Let's see. Objects represented in different number of dimensions do not exist. Okay, 0D, 1D, 2D, 4D, 10D, 26D, 1000D. Objects are not. These are abstractions of our mind. Yeah, they're not even abstractions of our mind. Anything which is 0, 1, 4 and upwards, you cannot even imagine. So it's not even in the mind. That's the first issue, okay? Again, they're confusing number lines for dimension. So you can't use the word dimension when you're going to talk about anything above 3 dimensions. There's no such monster. You cannot imagine a 90-degree angle to the 3 mutually perpendicular ones we're familiar with, length, width, and height. There is no 4th arrow perpendicular to those 3. No one can imagine such a monster, and that's not because we are stuck in this 3-dimensional world or subset of the 4D world. No, there is no 4D world except in the minds of mathematicians who confuse number lines with dimensions. That's why they talk about 4-dimensional world. And what's the 4th dimension? Time. Is time a dimension? No, it's a number line. Obviously, it's not a dimension. Time doesn't run perpendicular to length, width, and height, and they always show it running in Feynman diagrams, at least, perpendicular to what? To length, width, and height? No, they call it space. Space, like if space were a physical object. Okay, so let's get an answer to this gentleman. And here it is. Well, object is not equal to exist, and that's his first error. He's confusing object with exist, which is what David Hume and Immanuel Kant did. They confused object with exist. They thought there was no difference between these 2 words. No, there is a difference. Exist is an object that has location. Now, the first thing we have to notice that we do have to define the word object, because you can't do physics without an object. That's the golden non-negotiable principle of physics. Okay, and there is no provision for dimensionality in the definition of object. As you can see there, object, that which has shape, says nothing at all about dimensions. Okay, so you shouldn't bring dimensions in there or the word exist. It's too early to talk about the word exist, or dimensions for that matter. All shapes and all forms are welcome. So 2D shapes, 3D shapes are all objects according to that definition. Okay. The individual who harps on 2D or imaginary objects, such as the 3D table I'm thinking of, confuses ordinary speech with scientific language. Until you can get over that hurdle, you're not going to make any progress. Okay? So you can't confuse the dimensionality of an object with the definition of an object, and you can't confuse the word exist with the word object. Those belong to ordinary speech. People have the tendency to say, well, in everyday world we say an object is that which we can touch, an object is that which we can see. And that's wrong too, because we can't see the air. Okay? And we can't touch a triangle. What you're touching is the ink and the paper. With that, I'll see you on